Thanks very much for calling. Good afternoon, electrical colleagues. I have with me Ed Maki from Michigan Tech University. You should be able to see our agenda for today, and I'm going to quickly run through the proposals that went out to the NFPA. The National Electrical Code Committees. I'll mention that we are in a cycle of the National Electrical Safety Code. I hope we can talk a little bit more detail on that. If not, we can deal with that next week and next conference. And then finally, we'll let Ed give us a little bit of history on the Michigan Tech Power System. And then, of course, we'll meet again on December 2nd. So I also wanted to let you know that we now have we'll be transitioning to another website from IEEE. That website is going to be called the IEEE ICPS-EHE. I'll post it right here so you can see where the link is. But that will allow you to work with connect immediately with other electrical colleagues directly through the IEEE. We'll still continue to have some discussions with APA on this. Ryan and I, we remain the votes for APA on the National Electrical Code, but I thought I'd let you know that this particular site will be superseded by a site that looks a little bit more like this. And for the moment, we're keeping our National Electrical Code issues on this particular location. It's a little bit easier URL, as you can see. To summarize what we did is that there are 87 proposals were submitted last week, basically. No, November 7th, rather. And some of the ideas that were that were advanced had to do with clarifying Table 2-2012. As you know, we did get an exception there, but we wanted to get some clarifications there. We also wanted to correlate the occupancy use class with ASHRAE 90.1 with lighting power densities. By the way, these are actually on our, if you take a look here, let's see if I can let you see what we, excuse me, up here I believe. This is all 87, or is it 83, 87, 83 proposals. And so to give you an idea of what we did on 2-2012, I'm going to zip through here. And you'll see that, let's see, Article 2-2012, that we tried to drive in the ASHRAE. Yeah, here we go. And it may not be so easy to see here. So in any case, this is the table that designers use for designing lighting supply circuits. And what we discovered is that a lot of these occupancies are not relevant or not used very often, but in our industry these are occupancies. They are actually in the International Building Code, and we took the IBC occupancy type of occupancies, and then we took the unit load amperes from ASHRAE 90.1 and installed them here. So, for example, if we take this one, which is the most meaningful to us, ASHRAE says we're limited to 1.0 watts per square foot, and then he was asking us to design at 3.5 watts. As you know, we got an exception on that, but this is an example of what we tried to do to get some clarity on that, because some designers are struggling with it, and I hope that does help. So let's see, was there anything else here? Oh, excuse me. All right. So we're trying to get IEEE recommended practice driven into the NFPA 70 suite. Actually, it turns out that most of the proposals, about 25 of them were actually inspired by that. So if I go down to, let's pick one down here. Am I making you dizzy here, Ed?
No, this is fine.
Okay, all right. So what we're trying to say here is that so if we look at services, for example, instead of using the old red book, which is going to be superseded, we're asking, let's see if I can get a look. Can I zoom in a little bit more on that? Let's see. It will let me do that. Look at that. So we're saying go to this new 3001.2. It's recommended practice for evaluating electric service requirements of industrial in commercial power systems. So this is typical for about 40 others. So while it may sound like a feat to have gotten 87 proposals, that about half of them were inspired by that. So really we only netted about 40, 45. Okay. Another area where we wanted to get a little bit more, we wanted to put more effort into identifying that impedance grounding is possible for our industry. So if we go to Article 250 here, so this is 310. If they are in order here, this is 240, so the next one should be 250. 250. Article 250, 250-36, I believe it. Okay, so what was said here is that impedance normally selected. So this is what allows any designer to install impedance grounding. As you know, all the advantages of impedance grounding seem to override many of the objections. There are some drawbacks, as with any engineering approach, but statistically they're less likely now, and the need for reduced arc flash and greater reliability is driven by this. So what we're trying to drive here. We'd like to see more impedance grounding, and I believe I even here we go. I recommended an informational note here that impedance grounding is recommended for power systems that require a high degree of reliability. So I felt that this would make it more visible to designers. Remember, the NEC is principally a safety code, but if we make these options available to designers and you have management that aggressively looks for possibilities for increasing safety and reliability, this would be one of the first places we'd look. So what else did we do here? We said we'd like to identify campuses as supervised installations. There's some allowances that are permitted when you do that. We're going to be changing some, since we're at it, I wanted to show you something that might disturb a few people, but it would not be the first time some of you have seen this. And I'm proposing that we look at our tables, our wiring tables. And Ed, I don't mind if you give me a hard time about this. Look what I just did. This is the second cycle where I've made this proposal. What I'm suggesting is that you can get 15 more amps out of a number 2, 15 more amps out of a number 2 at that level, another 10 amps out of here. So you know, I don't mind being put on the spot here, Ed. When an electrical guy sees somebody doing this, what do you think?
Well, I don't know. I feel that because it depends on the insulation and where it is. I suppose in many cases you can get more current, you know, through the wire.
Yeah, I won't go through it today, but you actually farther up that particular passage, you will see that the Nair-McGrath oh, here we are. You can see it. Right here, they actually lay out the equation. It's because it's been PDF, you won't see it. But designers are always able to use this if you use these temperatures. But what this table is, this tends to be the table that that AEs will put on the specifications and the drawings, and they'll say refer to table 310.15 or 310.16, or used to be 310.16, and this is how you specify your wires. When actually, especially at the higher levels, and if you're careful about it, you actually can get more current through your larger feeders. But there's a lot more science that has to happen here, and I don't deny, and I even say that here, that this is the second time. I don't have any illusions that this is going to be anything easy to do, but it was proposed in the last revision cycle. We know that we don't expect the committee to accept this proposal, but I do want to see it tracking in the public record. We know that, for example, some of the European Union, the IEC, wiring practices usually result in circuit makeups, feeders, and conductors much lower than ours. And we feel that this might be a time to look at that. Now, I'm all for making sure that a wire doesn't turn into a fuse. We've got that, but we also have overcurrent devices. So many things have to move together to do this, but I wanted to make sure it got on the agenda. You had some thoughts, Ed?
No, you're doing good.
Okay, good. So finally, there are some other, so that's probably the least disruptive. We're asking for, this is our colleague Dan Brimmer asked for something like this, more strengthening of, we want more clarity in the aluminum wiring, and then strengthening the user owner interest. This is something we're doing at the state of Michigan level. So in any case, I did coordinate some of these. So that's basically the overview of what happened on November 7th when we got all that in, and that's what happened since the last teleconference. So that's the dry part of this. That's the dry part of this teleconference this week. And also remember that we still have this project here where we're attempting to try to get the we'd like to get data for our feeders. And if I go back here, it seems to me I didn't get the right link. Here we go. So if I hit this one here, this is a project that is being administered. Well, let's put it this way. I'm trying to get funding for it. I've had some success with it. But here's where we actually get into the feeder and these branch circuit measurements. We want our proposals to be data driven. Even the wiring one. But we think that if we get more data about how power is actually being consumed within the building, well, actually we have that data. It's just that the wire and the switch gear that gets that is what we're struggling with. The reason we were able to get that last code change was that we had easily obtainable service meter data. It's harder to get branch circuits and feeders, as you know. So we are running into a time constraint here, and I don't want to take any minutes away from Ed. So we'll deal with the National Electrical Safety Code, which is entering another revision cycle. As always, all of the electrical, all of this is open to the public, and you can, you're welcome to see all the different draft proposals we have here. And we'll have another meeting on the 2nd. I'll let you know that the IEEE Electrical Education and Healthcare Facilities Electrotechnology Committee will be meeting online internationally on December 18th. So this is one where we selected to be the correct time frame. It may well be as we start, as the IEEE EHE committee begins to take off, that we'll likely have the international conference every other week, because there is a time zone issue that's significant, especially if we expect our European colleagues to contribute. It's important for our industry, in my estimation, because so much of the good work in wise use of materials is occurring in the European Union. They substitute their material limits with crafty engineering. I've always admired that. You can see a lot of that, particularly in some of the Siemens products. And so I'll leave it at that. So just be aware that we'll meet again. I don't like to pester people with reminder emails any more than necessary. So you'll get some word on that, and then you'll probably get the formal IEEE website. You'll see that by next week. It's already set up for us. I just didn't want to show it prematurely. So in any case, at this point then, Ed, I'd like to turn this over to you, but not before I give you a chance for any comments on this brief update since the last meeting.
You mean for me?
Yeah, I'm ready to turn the airplane over to you. But I thought if you had any comments or observations.
Well, yeah, no. I don't know, like I said, it's really interesting what's happening, and I guess I haven't supplied any information, but I guess I'll just keep watching what you're doing, when I can.
Okay.
So,
All right, fair enough. We know that people are busy. This is very often not the first thing that their boss wants them to do. I think it should be the first because standards underlie just about everything we do. We're just not aware of it, and we're not aware about the ferocious pace at which things happen. But at the moment, we have the privilege of learning more about the Michigan Tech system, and since this does go internationally, I think what I'll do is I'll get the Michigan Tech map up there so people can see just geographically where Michigan Tech is. And let me get my Google map on here first. And it's in Houghton, which is called Michigan Technological University. Technological University. And here we go. It's a wonderful place. Great pasties, beer. So for our national, international colleagues, this is where we're located, and
a lot of snow.
A lot of snow. Actually, I can't resist the temptation to look at really what is going on. You have one of the better webcams. I'm kind of a webcam nut, and Michigan Tech has a good one. So if you don't mind me, let's take a look at what does the center of campus look like at this very moment. That's not hard to see. Oh, that's Michigan State. We don't want to go there, do we? We want to go to Michigan Tech, and that would be right here. Here we are. Oh boy. What is that? 2 feet of snow? 3 feet of drifting snow? What are we looking at there?
Yeah, it's a little over 2 feet. South of us, they've had 3 or 3.5 feet, but even though we have the lake effect.
Mm-hmm.
But
yeah, I guess. Yeah, I can see that.
Down. Yeah,
this is this gives our national, international colleagues a sense of where we're at right now. So let's let you talk about your power system, and let me turn all this other gimmicks off here, and let's see if we can get let's see if I can get your system up here. I just had it. Unfortunately, I hope I didn't lose it. Unfortunately, I might have lost it, and I'll have to pick it up again. Let's see, Maki. And I think this is what you gave me. And it should be coming up very shortly here. I just want it to open up. Let's see, open. Oops, it's not making it easy. All right, then let's just do this. Sorry it's taking so long to call it up. When you're navigating many windows like this, it sometimes gets... okay, I like this view.
Yeah.
Okay, so where would you like to start, Ed?
Well, right here, I guess.
I'm going to give you the mouse. So at the very least, you have control. Okay. You can zoom around a bit if you know how to do that. There we go. Okay.
Yeah. Okay. Of course, we still are fed by UPCO, Upper Peninsula Power Company, but we do buy our power from Wolverine downstate there to get a little better price. But originally, in 1967, 68, we went underground with our system. Otherwise, we had poles like many campuses, poles and overhead wire, and of course, we didn't have as many buildings, but new ones were coming on in this area here. And so we did go underground with 2 feeder cables of 500 MCM, and the voltage was 12,470. They had from a UPCO transformer, they got it to our substation at 69,000 volts. So so we had these 2 feeders running throughout campus, and then our dorms and student housing was still overhead for quite a while, but eventually then we put in new switches, S&C switches, so forth, and then had 3 feeders at 500 MCM cable, and then 12,470 on the voltage. And about 10 years ago, we actually put in 4 2.2 megawatt generators. They're diesel generators, or CATs. And so UPCO was telling us if they tell us to go offline sometimes, then we'd have to go offline, and of course we got a price reduction on that.
Interruptible rate? Or
yeah, interruptible rate. So that's how we got the generators, but right now, of course, buying it from Wolverine, I'm not sure if we need it or not, but anytime there's a power outage in UPCO or elsewhere, well, we can become an island, or else we can become an island if they're working on the high voltage line or something like that.
Mm-hmm. So what I'm seeing up there is what, 8.8 megawatts of generation?
Yes.
Mm-hmm. And is that the average load for you, peak load? Are you comfortable?
No. The load actually is around, in the winter, is about 5. So we have 5.5 maybe, but we do have at least an extra generator in case one goes down.
Okay. So the entire campus is supplied at 5.5 megs?
Yes.
Okay.
We do have emergency generators, of course, in most of the buildings, the bigger buildings, and of course that's for the safety code, in case we have some other problem with our system. And we are now, even though we left off for a while, but we are looking at all the high voltage and then the main feeder breakers or switches in each building in the summer to do maintenance on them and test them. In fact, we're having the breakers tested because some of them are quite large, like 4,500 amps.
The secondary breakers, the 480 volt breakers?
Yes, the 480 or the 208.
Mm-hmm.
Field buildings are quite high.
Mm-hmm.
So I guess and in some cases we feed other buildings from one emergency generator in another building, so that's kind of sharing the emergency load. But yeah, I guess I should mention I did go through and did analysis of the arc flash on the electrical equipment and mains and so forth. So we did get that labeled in most cases throughout all the buildings. So,
do you have any incident energy that would be require PPE greater than 4, for example?
Pardon? Yeah. And in fact, on let's say 2,000 kVA transformers. Well, the transformer and then the first main subfeeds, I did get some that were beyond 4, so they were danger. So we have to shut them down to take to do any work on them.
Mm-hmm.
The other thing is we do have we've got a new thermal camera, and the plan is to have the electricians, of course, open up with their gear and everything, of course, PPE gear and so forth to take pictures of where there might be some loose connections or something. We've always done that for the high voltage, but of course even now that has to be done with the gear the gear on.
Mm-hmm.
So basically that said, we went, like I said, we went underground and got 3 feeders, which comes in handy when you want to work on one building. You can put all, we can actually, especially in the summer, put all the buildings on 1 feeder and have 2 shut off. So it does work that way.
Yeah, so I see two feeders tapped off the load side of each of these 300 amp switches. And so on the matter of arc flash, the reason I raised that question is that we did one of the issues that we brought up here was this the use of impedance grounding. And it's important in your case is that unless the utility will let you do it, typically it's not done. And we know that many utilities in the West Coast, I'm say University of Washington, Berkeley, they're all allowed to do it, and their incident energy goes down in a very large way. You're limiting current to 100 to 1,000 amps when it used to be 1,000 to 10,000 amps. And so that's a big difference in safety. Of course, what I'm seeing here is, I don't know if you have any instrumentation on your switchgear here. You probably do. But with fuses, in our case, we have a lot of circuit breakers, and we have a couple things we have to consider that in some regimes that the phase-to-phase ground in an impedance ground system isn't picked up right away. It's one of the more statistically less likely. Most faults are solid ground. We feel that by at least it's my judgment, and it seems to be the judgment of large parts of the process control industry, that impedance grounding is worth the trade-offs. So certainly in our space, organizations need to look at that. We're probably going to do a special breakout session with that on a couple impedance manufacturers. The best people in this business are the ones that are working for the auto companies and the data centers. They are all, it's pretty much settled science for them. It's been that way for decades in those industries. But in the building premises wiring system, and if you consider that the Michigan Tech system here is a premise wire system, right? So arguably, even though you have many buildings here, it's likely that your service starts here. This is where your electrical inspector, your city inspector might say, all right, this is where the service is, and I don't care about anything going on downstream. In other cases,
yeah, that's true.
Yeah. So in other cases, that same inspection authority may look at this substation, say right here, and he'll say, well, wait, all this is utility wiring, and this is where my focus of my inspection is going to be. So who does your inspection there, Ed?
Well, for our new building, it's usually the state inspectors, and smaller things on a contractor project, we'd probably have the local county inspector come in. And in some cases, of course, it's not necessarily inspected, but we do. The electricians, of course, are required to build the code.
Yeah.
But we don't have to have somebody come into the individual buildings, and inspect it unless it's a major project.
Yeah, well, generally, I think the commissioning people are right to say we'll go through this, and they'll look at your switchgear, and I never really complain too much about additional inspection. I'm more interested in larger concepts, difficult issues, stuff that's impossible to do. That kind of interests me. So driving a practice that's been going on for about 100 years. into our industry, which is the one that seems to be asking for more reliability, especially in the hospitals. This is a near silver bullet, but until AEs hire the electrical engineers are comfortable doing this, and that we have a migration path. It's very difficult to migrate to this kind of a system when you've already got a. Let me see if I can find your long line again. Where are we? See how easy it is to lose this? There we go. Okay. So another question, you'd mentioned that you're using generators, on-site generators. So I'm assuming, if I look at your, if I can get your Google map back up here again, that you're surrounded by a utility, and that at some point, because you're surrounded by a utility, that there's buildings on the periphery. Is that? I'll say there's a core campus here, and where roughly does your service come in here, Ed?
Well, it's
you can yeah, there you go. Yeah, you can use your mouse.
yeah, it's right there.
Mm-hmm. Okay, what is the boundary of the utility then? Is it basically the boundary, the property boundary of the campus?
Well, actually, can you see my mouse? Okay, well, actually, our utility goes all the way around here, plus it goes to the student, well, this is forestry building, but it goes to the student development complex too.
Mm-hmm.
And then this way is married student housing. So even these were last on poles, but they're now pad mounts to each apartment house.
Mm-hmm.
So it covers quite an area. This is City of Houghton right here.
Yeah. Uh-huh. Well, I bring this up because if you had a district energy system, and you don't, but I try to drive home the point that you are able to use the perimeter utility as your backup power source. It's been in the NFPA 110 for many years, many cycles. It's a fairly durable permissive statement, which means that if you have a district energy system like we do, any building that's on the periphery of your campus, you don't need an on-site generator. You don't need an on-site generator, and that's kind of a
you mean just use UPCO?
Yeah, and that's something that makes a lot of the design community squeamish, but the numbers are fairly clear. That's part of what one of my campaigns have been over the number of years. We've written a number of papers on that. I won't, but it's like so many things. It's acclimating your design and engineering culture to do that. So I'll just say that we've done it here, and you'll probably, when I mentioned my colleagues here, Robert Arno, they are all active, especially Robert and Neil Dowling are on the front end of that of the mathematics to make that determinant. So I'll just close this teleconference by saying that we did cover this issue of power system reliability. This is a proposal that they put in, and it has to do with trying to evaluate your reliability choices. And we focused on healthcare systems because we felt that large campuses would need a more numerical treatment. Right now they're just doing what we did last time. The AE wants to get in and out and get its design fee. And it's just one of those approaches that falls between the cracks, and it's an enormous one. It's a huge issue to be able to increase your reliability 1 or 2 nines. And then to reduce your arc flash from 4, PPE 4 to 1. Those are big issues, but until you can get the designers to do it. We've actually built one of those backup power systems here at U of M. For security reasons, we don't advertise it too much, but just suffice to say, actually, we actually, if you go back to our home site here, we do try to describe it in where do we describe it? Describe it in an article. Here we go. It would be this article here that was published in the Planners Journal. We felt that the planners And the planners would be the first to benefit from fewer generators that actually give you fewer, but actually statistically better reliability. Another non-reliability, and that startles many people in our industry. So I think we do have our time limit here, and I'm very grateful for your time and expertise, Ed. We'll be uploading this in the next day or two, and I hope it benefits the industry. And we're always, you and I are welcome to talk even before this here, and I'll start to roll out more information about the new website, the IEEE website, where most of these ideas. We'll probably let this. We'll probably, since this has worked so well for us, use it as an underlying workspace, but our front end will look a little bit different. It'll look a little bit more like this, and you'll see how that develops. And also the IEEE website will allow more electrical people to get into an area where they can talk to other electricals on some of the specific technical economic problems we face. So with that, I guess it's time to close. Do you have anything else? Any final reflections? Any thoughts you wanted to convey to the others, Ed?
No, except it's been, I've had fun working, at Michigan Tech and so forth, and I guess there was a lot of things happening through the years, and I guess that's about it.
Okay, Ed. Well, I'll talk to you in a few days here about other issues, but for the moment, thanks very much for our electrical colleagues, and we will see you on the 2nd. Bye.
Okay.